I'm sure you're having a great day, guys. We are ready for the analysis on the RC world, the RC passage that I posted a couple of days ago. In this particular analysis, I will be focusing on the RC that I posted, plus the very basic aspects of attempting an RC, that is reading comprehension, which you must undertake if you want to excel at critical reasoning. So here is the analysis for you guys. Let us first of all take a moment and read the RC that I gave. You can pause this video for a while, read it, and then we begin. I'll give you a couple of seconds for that. Understanding an RC is very important. I can bet myself, if somebody can prove that just by reading the first paragraph and the last paragraph, you are able to generate main idea. Yes, it might be possible, but this is a very misleading statement that a lot of people claim. And that is the reason why people who do RC in this manner, they generally do not get correct answers, or they are not generally that confident. So for an RC to really get into you, you must be a good reader, or you must start right now to become a good reader. I'll come back to that. But first of all, let us see how you go deep into an RC understanding. Whenever we talk about taking care of any RC, and I'm meaning it, any RC, any passage, there are three things that are highly important. First, you got to understand the passage. Understand the passage. It is not simply about reading something and trying to find out answers wherein certain answers are similar to each other. That is not what we intend to do. When I say I have to understand the passage, I must visualize the overall idea. Guys, focus on this word known as visualize. If something is being read here, or if you are reading something, you must be visualizing it sort of pictorially as to what is happening. You must be feeling it. Now, it might be a very far-fetched idea in the way I am talking, but no, it's not actually the case. When you read an RC, when you speed read an RC rather, still also you can visualize the overall idea. Okay, this is the way the structure is flowing. This is the way my story is progressing. All these keywords are changing the mood of this entire passage. What is happening here? What is happening there? All these things you can actually feel. The moment you do not feel an RC, consider it that you have not understood an RC. And if you haven't understood the RC, believe you me, you will not be able to attempt the questions confidently. Second thing is you got to pick a strategy. There could be variety of strategies. First, you may glance at questions and then read the passage. Second, you may read the passage first, then you glance at questions. Or otherwise, you can alternate. When I talk about alternate, I talk about reading the questions, reading the passage simultaneously or one after the other. And the strategy depends on how long is your passage, how complex is your passage, which specific exam are you attempting. For example, in case of IIFT, your passages are way too long. In that case, you might want to read one or two questions first, and then you simply go on and read your passage quickly, and you would know where you will find the answer. But in case of CAT or GMAT or GRE, where critical reasoning is something that is highly focused upon, you might have to choose a different route. The passages are a little smaller, but they are highly intense. And the third thing is to eliminate the options. Elimination is the primary aspect when we take care of an RC. So you got to read your options carefully. You got to eliminate those generic, far-fetched ideas that seem to be an answer, but they are actually not. And the third and the most important thing when you are eliminating is whenever you eliminate something, you definitely eliminate it, but something that you are not sure, you shortlist it. You never try to find out an answer in the very first round of elimination. For example, if there are 5 choices, you eliminate 3 choices. 2 choices you are not sure about, you simply shortlist them. And then you may go back to your RC if the need be, and then find out which keyword relates to which word. I am talking in a very jargon-based manner, but it is very important right now. And now I will again jump to the same RC that we discussed. that we attempted, and I'll transform this jargon into the actual idea. So here we go. When we read the RC, we have to understand certain things. Now I will read it with you. Around 1960, mathematician Edward Lorenz found unexpected behavior. Unexpected. In apparently simple equations representing atmospheric airflows. I need to find out what is unexpected. Whenever he ran his model with the same inputs, different outputs resulted, although the model lacked any random elements. So we are talking about something like this. Whenever he ran his model with same inputs, if inputs are going in same, there are different outputs are coming. But he says, although the model lacked any random elements. Now, if you give same inputs to a same black box, you ideally should get same output, unless there is some random activity that is happening over there. But he says that without any random elements into it, with same inputs, different outputs were there, and this was an unexpected behavior. Great. I got the idea of the RC that he is going to explain something about this model and maybe the experiment that he is doing or whatever. Let's see more. Lawrence realized that the tiny rounding errors in his analog computer mushroomed over time, leading to erratic results. His findings marked a seminal moment in the development of chaos theory, which, despite its name, has little to do with randomness. His findings marked a seminal moment. That means now something has transformed the entire course of history. Let's see how. Lorentz realized that tiny rounding errors that were mushroomed over time led to erratic results. That means even if the random elements are not there, if time is given to a particular system, then different outputs can come even if the inputs are the same. And this particular thing marked a seminal moment in the development of chaos theory, which, despite its name, has little to do with randomness. Wow, I now got it that he has found out something really unexpected, and that unexpected behavior was that time is also an element which can lead to chaotic or different types of result, different types of outputs, even if there is no randomness included in the system. Great. The very thing that I must understand is now he must expand his argument. He must give me certain examples, and that is probably something that is given in the second paragraph. To understand how unpredictability can arise from deterministic equations which do not involve chance outcomes, consider the non-chaotic system of two poppy seeds placed in a round bowl. Unpredictability arising from deterministic equation. Deterministic equation means something that is fixed. Unpredictability is something that I cannot predict. These are my keywords, guys. To understand how unpredictability can arise from deterministic equations, he says you got to consider a non-chaotic system of two poppy seeds. Now probably he will explain me how using deterministic equations or deterministic inputs, something that we know, how can we understand something that we do not know? From something that we know, how can we understand something that we do not know using this non-chaotic system of two poppy seeds? As the seeds roll to the bowl center, now imagine, this is where visualization comes into picture. Imagine there is a round bowl, right? And you just put two poppy seeds from two sides of that round bowl and you leave them. As the seeds roll to the bowl center, a position known as point attractor, the distance between the seeds shrink. Absolutely. If the seeds are coming down, the distance between them is shrinking. If instead, another keyword, if instead the bowl is flipped over, the two seeds placed on the top will roll away. Imagine a katori that is there at your home, right? This is what he's doing. That just if you change the, if you simply change the sides of the bowl, if you're putting the seeds within or if you're putting the seeds above it, the seeds will exhibit two different types of motion. Such a system, while still technically chaotic, enlarges initial difference in the position. Chaotic systems such as machine mixing bread dough are characterized by both attraction and repulsion. Now he goes on to explain more chaotic systems like machine mixing bread dough. What is a chaotic system, guys? Chaotic system means something that is not fixed. So if there is a machine that is mixing a bread dough, or imagine if you are stirring some sugar into some water in the glass, it's a chaotic system, right? You don't know what's going to happen, how it is happening and everything. As the dough is stretched, folded, and pressed back together, any poppy seeds sprinkled in are intermixed seemingly at random. Means it seems that if the dough is being kneaded and if you're putting some poppy seeds in it, with time probably we'll feel that the intermixing is happening at random. But this randomness is illusory. But now change. He says that if you're putting some salt, for example, in a dough that you are kneading, you will feel that they are being mixed at random, but this randomness is illusory. This is an illusion. In fact, the poppy seeds are captured by strange attractors, staggeringly complex pathways whose tangles appear accidental but in fact determined by the system's fundamental equations. Even if I do not understand this thing, I do understand one thing, that what is happening is that this is not random because these seeds are captured by the strange attractors, which are these staggeringly complex pathways, which appears to be accidental. That means when you are kneading, the poppy seeds are moving back and forth and whatnot wherever. These are so complex pathways, but they are actually determined by the system's fundamental equations. That means initial system setup is actually determining those complex pathways. These are not random. During the dough kneading process, two poppy seeds positioned next to each other eventually would go their separate ways. Any early divergence or measurement error is repeatedly amplified by mixing until the position of any seed becomes effectively unpredictable. When I talk about this thing, it means that the moment you put seeds into it, initially they will go their separate ways. But the more you stir, the more you keep on doing the same thing, this measurement error is repeatedly amplified by mixing, right? The more you mix, the error is increasing. But there will come a time when the position of seed will become effectively unpredictable. It is the sensitive dependence on initial condition. It is this and not the true randomness that generates unpredictability in chaotic systems. That is what he said in the very first paragraph. That is, it is the dependence on initial condition that generates unpredictability in chaotic systems. Randomness doesn't generate unpredictability. It is the sensitive dependence. That means very prominent dependence on initial conditions generates unpredictability. If the initial conditions are creating unpredictability in chaotic systems, so he was right that this is an unexpected behavior. That means even if you put same inputs, but because it is highly dependent on the initial conditions when you put the inputs, what were the equations then? Your output will be different even if it doesn't have any random element. Great. And he says that one such example is Earth's weather. According to the popular interpretation of the butterfly effect, take care of all these things that are in quotes. Okay. According to the popular interpretation of the butterfly effect, a butterfly flapping its wings caused hurricanes. A better understanding is that the butterfly causes uncertainty about precise state of air. So if a butterfly is simply flapping its wings, it is causing uncertainty about that air, right? But maybe butterfly is doing it for long time, that what is going to happen probably becomes unpredictable. Even if I have to simply think that this is what he intends to say, let us read it further. A better understanding is that butterfly causes uncertainty about the precise state of air, this microscopic uncertainty grows until it encompasses even hurricanes. That means if it keeps on fluttering, it is becoming so uncertain that after repeated flapping of its wings for so many times, the uncertainty grows that it encompasses even hurricanes. That means probably that's how hurricanes result. Few meteorologists believe that we will ever be able to predict rain or shine for a particular day years in future. Isn't it great? They again justify it that it is still very difficult for us to predict rain or shine. And once now we have understood the RC, I definitely know that it is about change in the chaotic theory, chaos theory. Now let us go back and see how I am going to attempt the questions. The main purpose of this passage is to explain complicated aspect of certain physical system. Yes, it is complicated. There are certain physical system that the author has already given. Probably is trying to explain these complicated aspects only because he's saying that something that you actually thought is very easy, predictable is actually not. So I will shortlist it. Trace the historical development of a scientific theory. No, we are not even talking about any scientific theory and no historical development. Distinguish a mathematical pattern from its opposite. Okay, I might shortlist it for a while that I got to distinguish a mathematical pattern because normally I believe in something which is that chaos theory is based on randomness, but now I'm trying to distinguish it because it says that chaos theory depends on initial conditions. I'll shortlist it. Describe the spread of a technical model from one field of study to others. Not even said. Contrast possible causes of weather phenomena. Absolutely not. It is just an example that they have given. It's not the main purpose. Main purpose means if you read it, you will know the content of the passage. More or less, you can say that it is a little elaborate form of the title. And what this entire passage talks about, that there has been something very different happening to certain physical systems. And one part of it is mathematics. It's just the part. So the answer is first, explain complicated aspects of certain physical systems. In the example discussed in the passage, what is true about poppy seeds in the bread dough once the dough has been thoroughly mixed? All right. I would like you to take a moment, pause the video, and think about this answer in the manner that we have discussed. All right, now we see. They have been individually stretched and folded over like miniature versions of entire dough. They are scattered in random clumps throughout the dough. Random clumps throughout the dough. They are accidentally caught in tangled objects called strange attractors. They are bound to regularly dispersed patterns of point attractors. They are in positions dictated by underlying equations that govern the mixing process. In this example, they say that poppy seeds that we put in bread dough, when we mix them, initially the uncertainty grows, right? The error grows. But once you have done it thoroughly, what is true about poppy seeds? That you probably would not know where these poppy seeds are. And there is no randomness that is involved. And hence, it is probably because that they are in position dictated by the underlying equations that govern the mixing process. Why? Because your passage says that if you put a ball straight, then the poppy seeds will come close. If you put a ball in a reverse fashion, then the poppy seeds will go uh, against each other, as in the distance between the poppy seeds will grow. Then it talks about the dough mixing process, that as you keep on mixing it, there are so much complex pathways that are dependent on these initial conditions. And because of that complexity, the uncertainty will come up. It's not the randomness. And every other option is simply talking about that randomness. According to the passage, the rounding error in Lorentz model, okay, were at least partially expected given the complexity of actual atmosphere. Was it expected? Okay, let's see. Rounding error. According to the passage, the rounding error in a Lorentz model. He talks about that initially the error will increase. Gradually it will increase, but after repeated mixing of the dough, after repeated application of the same process, the complex pathways will make this entire thing so unpredictable. Not because of randomness, but because of the complexity of the initial conditions. So when we say that were at least partially expected, given the complexity of actual atmosphere, we're not even talking about that. Shrank to insignificant levels during each trial of the model. No, actually it grew. The rounding error grew. Indicated that the model was programmed in a fundamentally faulty way. Never ever it was said. Were deliberately included to represent tiny fluctuations in atmospheric air currents. Where did this come from? Were imperceptibly small at first, but as you keep on mixing it, because of those complex pathways, things will become so unpredictable. But it is not because of randomness. So they were imperceptibly small at first, but tended to grow. The passage mentions each of the following as an example or potential example of a chaotic or non-chaotic system, except, that means all uh, these five options are there. Passage mentions each of the following as an example or a potential example of either a chaotic or a non-chaotic system, except what? So something that is not given. All you have to find. It's very data oriented thing. A dough mixing machine? Yes. Atmospheric weather patterns? Yes. Poppy seeds placed in upside ball? Yes. Poppy seed placed in a right side up ball? Now it is not given, but what it says, or a potential example. With respect to the bowl, it only talked about the upside and the inverted, right? But it could be any way. All it says that it depends on the initial condition. But fluctuating butterfly flight patterns of butterfly are not given. It is just the fluttering. It can be inferred from the passage that which of the following pair of items would most likely follow typical pathways within a chaotic system. Two particles ejected in random directions from the same decaying atomic nucleus. The passage talks about constant application of something which will result in the uncertainty. So this is something that you have to map here. Once you eject two particles, the job is done. You are not acting on it. If you're not acting on it multiple times, then how can you create that uncertainty? It will not talk about it. Two stickers affixed to a balloon. Once you affix two stickers to a balloon, so if you expand and contract it, the position of balloon is not changing. The position of stickers is not changing. That means you are not creating a lot of stirring into it. If I talk about that dough mixing equation. Two avalanches sliding down the opposite sides of mountain. Again, avalanches are sliding down, but it is not that avalanches are then going up and coming from some other direction and all that stuff is happening, so that we cannot even predict where the avalanche will go. It is a thing that has happened once and not repeated. Two baseballs placed into an active tumble dryer. Now you put it in active tumble dryer, right? And then you don't know what is happening inside. So after some time, when it will keep on going, you will not know where the baseballs exactly will be. The uncertainty. That is the answer. Two coins flipped into a large one. Done. You clicked it, it's done. Where is that repeated action? That is what it talks about. So this is how you attempt an RC. Now guys, I do understand that I took some good amount of time in explaining this to you. which is very natural. But when we actually attempt an RC, we do not have a lot of time luxury. That is where practice comes into picture. So you must know how to practice. It requires a lot of reading. It requires a lot of understanding. And as we will come up with more and more RCs and more questions, more videos, all these things will keep on becoming clear. What I would want to leave you with is that, guys, pick up a book and complete it within 1 week. If you are able to do that, there is a great hope for you. If you are not able to do that, don't worry, I'm still there. So if you have any feedback, which I'm sure you would be having, please post that, and queries also in the comment section. And once again, we'll come back with more of such stuff very soon. See you. Bye bye.